Hello friends, I welcome you in lecture number 9 on hypothesis testing. In this lecture also we will discuss one more question on two sample Z test. Now we are familiar with two sample Z test and we know how we can compare two population means using two sample Z test. So if you have not seen lectures from lecture number 1 to 8, I suggest you to watch those lectures first and then go for these lectures, because all the topics are dependent and we should first start with large sample test for single mean, and then we should go for large sample test for difference of means, because this two sample Z test is generalization of single sample Z test. If we recall, we know that if we have one sample, then one sample Z test is Z equal to x bar minus mu divided by sigma over square root of n. And instead of sampling distribution of x bar, if we are considering sampling distribution of x bar minus y bar, that is if we want to compare two population means using two sample means, then corresponding Z statistic is Z equal to x bar minus y bar minus, instead of mu we have to consider difference between two population means divided by sigma 1 square over n1 plus sigma 2 square over n2. So whatever we have discussed for one sample, we are generalizing that concept to two sample. That is the reason this is called one sample Z statistic and this is known as two sample Z statistic. So you must be clear about all these things, and now we try to answer this question which was asked in GTU Summer 2022 exam. First we understand what is this given information. The means of two samples of sizes 1000 and 2000 are 67.5 cm and 68 cm respectively. Here we are given data for two samples. If we denote first sample mean by x bar and second sample mean by y bar, then it is given that if we are considering sample of size 1000, then its sample mean is given as 67.5 cm, and for another sample of size n2 equal to 2000, sample mean is given as 68 cm. So we are given two samples which are selected from populations with these sample sizes and these sample means. Can the samples be regarded as drawn from the same population of standard deviation 2 cm? So the question is, can we regard this sample as drawn from the same population whose standard deviation is 2 cm? So here we have to answer this question. You can see two sample means are 67.5 cm and 68 cm. So we can see they are nearly equal. These two values 67.5 and 68 are nearly equal. So from this we can make the question that if this is for sample, we have two sample means and we have these two sample means are nearly equal. So the question is, if these two sample means are nearly equal, then can we say that the two samples have come or have been drawn from the same population with standard deviation sigma equal to 2 cm? So that question we have to answer, and that question arises because of these two values. These two values are for two sample means and they are nearly equal. So from this, can we infer that two population means are also equal, and for that we have to consider alternative hypothesis as we can consider alternative hypothesis as that two population means are not equal. That means we can consider alternative hypothesis as that the two samples are not from the same population, and its negative statement is null hypothesis, that is two samples are coming from the same population, therefore population means are equal. And it is given that we have to answer the question that two samples are coming from the same population whose standard deviation is sigma equal to 2 centimeter. So we can consider population standard deviation for both the samples as 2 centimeter. So we have to test this null hypothesis against this alternative hypothesis. What is meaning of mu1 equal to mu2? That means population means are equal, or there is no significant difference between the two population means. Or we can say, in terms of this question, we can consider null hypothesis as that the two samples are drawn from the same population, and alternative hypothesis is two samples are not being drawn from the same population. So we have to test this null hypothesis with these values of samples and standard deviation equal to 2 centimeter, and level of significance is given as alpha equal to 0.05, and we can see here alternative hypothesis is mu1 is not equal to mu2. That means we have two-sided alternative, so we can apply two-tailed test. And because sample sizes are large, we can say that our sampling distribution will be approximately normal, and we have two-tailed test, so we will consider area alpha as the area which is in these two tails. So we have to divide our area alpha or level of significance into two parts. This area in both the tails is alpha by 2. This point is z suffix alpha by 2. This point is z suffix alpha by 2. And this is normal distribution, standard normal distribution. We know that if sample sizes are large, then z statistic follows normal distribution, and here alpha is given as 0.05. So this is going to be z suffix 0.025, and this is minus z suffix 0.025. And what is meaning of this? This area is alpha by 2, that means area to the right of this point z alpha by 2 is nothing but alpha by 2. So we have to decide value of z alpha by 2. Alpha by 2 is 0.025. We have to decide the value of z such that this probability is equal to 0.025, and we can write this probability as 1 minus probability that capital Z is less than Z suffix 0.025, that is going to be 0.025, and therefore from this I can write that probability that Z is less than Z suffix 0.025 is equal to 1 minus 0.025, that is going to be 0.975. So we will find from the cumulative standard normal probability table the value of Z 0.025 such that this area to the left of this Z 0.025 is 0.975. So for that we have to search for this value 0.975 in the cumulative probability table. So these are the cumulative probability tables. We are familiar with this table. In this table, I am interested in the value of Z such that probability that Z is to the left side of 0.025 is 0.975. So we will look for this value 0.975 in this table, and that will help us to decide this critical value of Z. So I am searching for 0.975 in this table, and you can see here I find 0.9750. So the value of Z in this row is 1.9, and here we can see that here the value corresponding to 0.975 is 0.06. So we have 1.9 plus 0.06, that turns out to be 1.96. That means probability that Z is less than 1.96 is nothing but 0.9750. That suggests us that value of this Z suffix 0.025 is 1.96. So using this table, we are able to decide these critical values. This point is now 1.96 and this point is minus 1.96, and these two regions are rejection region. So we will calculate value of Z statistic, and if value of Z statistic is to the right of this value, that is if it is greater than 1.96 or if it is less than minus 1.96, that is value of Z statistic is to the left of this value or to the right of this value, then we will reject the null hypothesis. And if value of Z falls between these two values, then we will fail to reject the null hypothesis. So all we have to find out is value of this Z statistic. So this is the procedure which I just discussed. Here I have written systematically all these things. First I have written given information. It is given that we have two samples of sizes 1000 and 2000 and corresponding sample means are 67.5 and 68 centimeters. We have to answer this question that can the samples be regarded as drawn from the same population of standard deviation 2 centimeter. So we consider alternative hypothesis as that samples are not coming from the same population, therefore they have different population means, and a negative statement of this is population means are equal. And because we are considering samples from the same population, for null hypothesis we write here that the standard deviation is 2 centimeter for both the populations, or because we are considering samples from the same population, the population standard deviation is 2 centimeter. In other words, we can write in this way also our null hypothesis. The samples have been drawn from the same population of standard deviation 2 centimeter, and because we have this type of inequality here, we can say that we have two-tailed test. There are two possibilities, either mu1 is less than mu2 or mu1 is greater than mu2. So we have two-sided alternatives, therefore we apply two-tailed test, and therefore we have to consider critical values as Z alpha by 2 and minus Z alpha by 2. Now sample sizes are 1000 and 2000, that means we have large samples. So we can write that since N1 and N2 are greater than 30, we apply two sample Z test. That means if we consider this test statistic, then this is going to be a standard normal random variable, and we test this we test null hypothesis H0 equal to mu1 equal to mu2 with this test statistic. So our assumption is that mu1 and mu2 are equal. We assume null hypothesis and we are testing this null hypothesis using this Z statistic. So we will consider mu1 equal to mu2, therefore this is going to be 0, and we are given that sigma 1 and sigma 2 are same, that is 2 centimeter, and we will substitute values of x bar, y bar, n1 and n2. So I have put all these values, and then I have to calculate all these quantities. So you can see this is going to be negative of 0.5. Here I can take 2 square common, and square root of 2 square is going to be 2. So that I have written here, and square root of 1 over 1000 plus 1 over 2000, and this I can rewrite as 2 over 2000, and I have plus 1 over 2000, so that I write as 3 over 2000, and I find out this square root as 0.0387. If I multiply this by 2, I obtain this value, and finally the calculated value of Z statistic is minus 6.4599. So this I have to compare with Z alpha minus Z alpha by 2 because it is negative. We have two-sided test and level of significance is 0.05. So as I discussed, we have to consider area in two tails. This 0.05 is divided into two tails as 0.025. So these two are rejection regions, and this region in the middle is non-rejection region that I have shown here. And as I discussed, now I know that if I consider probability that Z is greater than Z 0.025, then it is this area 0.025. This I can rewrite as 1 minus probability that Z is less than or equal to Z 0.025, and therefore this is going to be 0.9750, which I just explained in the beginning. And using standard normal probability table, I find that this area 0.9750 corresponds to this value of Z, 1.96. So this 1.96 is our critical value, and here it is negative minus Z 0.025. So this is our critical values. We have two critical values, minus 1.96 and 1.96, and calculated value of Z is minus 6.4599. So that is bigger than this value, smaller than this value. It can be somewhere here, minus 6 point something. So we can see it is in the rejection region. Calculated value of Z is less than minus Z alpha by 2, which is minus 1.96. So therefore we are in the rejection region. That means we reject the null hypothesis. And what was the null hypothesis? Null hypothesis was that samples are coming from the same population, but because we are rejecting the null hypothesis, conclusion is the samples cannot be regarded as drawn from the same population of standard deviation 2 centimeter, because calculated value of Z is less than tabulated value of Z, or it falls in the rejection region. So in this way we can decide that statement related to the population means. Here we are testing this statement mu1 equal to mu2 under the Z statistic. We are applying two sample Z test to test this null hypothesis, and we find that calculated value of Z is less than minus Z alpha by 2. Therefore we reject this null hypothesis, and therefore we can say that there is significant difference between these two population means. That means we cannot consider samples as come from the same population. So final answer is The samples cannot be regarded as drawn from the same population of standard deviation 2 centimeter. So this is second question about 2 sample Z test, and this was also asked in GTU Summer 2020 exam for 4 marks. So I hope now you are able to apply 2 sample Z test for testing the difference of means, and using this method now you can do this 2 sample Z test for questions like this. So this is all about this session. I hope you like it. Thanks for